In this lecture, we're going to look at how to solve polynomial equations by factoring. We're going to look at quadratic equations and I would say polynomial equations. And I will go further into that to explain what I mean by polynomial equations. So quadratic equations have this format: ax squared plus bx plus c equal to 0. Now to solve the quadratic equation, we will factor the quadratic equation and then we'll apply the product rule, and I'll show you what all of that means, and the result we get would be the zeros of the equation. So let's look at solving the quadratic first. So we have 1 here and negative 14, so we have negative 14, we have 1 and 14, 1 and 14, 2 and 7, 2 and 7. So I'm going to switch the negative position and see which of them meets our needs. So we need something that adds up to negative 5. So that's this right here. So we have this equal to 0. So x plus 2, x minus 7. So what this means here is that x plus 2 multiplied by x minus 7 equal to 0. Now there's a rule that if two terms, if the product of two terms gives us 0, then either of those two terms could be 0. So we're going to have case 1, x plus 2 equal to 0. So we subtract 2, so x equal to negative 2. And then case 2, x minus 7 equal to 0, plus 7, so x equal to 7. So the values of x equal to negative 2, 7. So that's what this is about. So negative 2 is a 0 of this function, 7 is a 0 of this function. Now if we wanted to put those in coordinate points, what we'll end up with is negative 2 and 0, comma 7 and 0. This will be useful for future courses. Let's apply the same thing here. We're looking for, so we have negative 90. So we're going to look at the factors: 1, 90, 2, 45, 3, 30, 5, 18, 6, 15. So let's look at this. We can see that which of these have a relationship that could lead us to 9. So 6 and 15 have a relationship that can lead us to 9, but we want a negative result after adding them up together. So we're going to put the negative sign in front of the larger number. So we have open parenthesis here, x minus 15, x plus 6. So using our product rule, we have to make sure that either of those terms is equal to 0 or x plus 6 equal to 0. So we add 15 here, we add 15 here. So x equal to 15. We subtract 6 on this side, so x equal to negative 6. So the values of x are negative 6 and 15. So now we have a situation where we're dealing with a greater than 1. So let's look at that. So 2 and 5 is going to give us 10. We have 1 and 10, we have 2 and 5. Because this is negative here, both terms have to be negative. So we're going to replace negative 7x with negative 2x minus 5x. So 2x squared minus 2x minus 5x plus 5 equal to 0. Now we're going to factor by grouping. So we have 2x, x minus 1, then minus 5, x minus 1 equal to 0. So terms in the parentheses are equal. So we have 2x minus 5, x minus 1 equal to 0. So now we have to apply the product rule. So 2x minus 5 equal to 0, or x minus 1 equal to 0. 5, add 5 here, add 1 here. So 2x equal to 5 divided by 2, divide by 2, x equal to 1. So x is 5 over 2, or 1. Or you could say x equal to 1, 5 over 2. Now we're going to look at another quadratic equation. So 3 and 13 gives us 39, negative 39. So we have 1 and 39. It's not going to work. We have 3 and 13. Because we have a negative 10, we're going to put the negative sign right here. So we have 3x squared minus 3x minus 13x. Sorry, it's plus 3x minus 13x minus 13 equal to 0. So we're going to factor this by grouping. So we factor out 3x, and we have x plus 1. And we factor out negative 13, and we have x plus 1 equal to 0. So terms in the parentheses are the same. So we can now get our factors. 3x minus 13, x plus 1 equal to 0. So product rule, 3x minus 13 equal to 0, x plus 1 equal to 0, minus 1, minus 1, plus 13 on both sides. So 3x equal to 13. So divide by 3 to get the value of x, and then x equal to 1. So x is 13 over 3 and 1. Now we have a polynomial equation. So I'm going to just, for this example, I'm just going to use polynomials. Although quadratic is a term of a polynomial, but I want to separate this by having anyone with a term where the leading term, which is this term right here, where n, the exponent, is greater than 2. So this example I'm using here, we're just going to use grouping. So I'm going to group this together, this together. So 12x cubed and negative 8x squared. So we can say 4x squared is a good factor here. 4x squared, and then we have 3x minus 2. And then a good factor here is negative 25. And then we have 3x minus 2. So now what we have here is we have 4x squared minus 25 and 3x minus 2 equal to 0. So now we apply the product rule. So 4x squared minus 25 equal to 0. 3x minus 2 equal to 0. So we add 25 here, we add 25 on this side, we add 2 here, we add 2 here. So 4x squared equal to 25. Divide this by 4. This here, 3x equal to 2. So we divide by 3. So here we have x squared is equal to 25 over 4. So x is plus or minus square root of 25 over 4. So this is x is plus or minus square root of 25 is 5, square root of 4 is 2. And then here x is 2/3. So your possible values for x are minus 5 over 2, 5 over 2, and 2 over 3.